Wow, this is so neat. This must be an electronic classroom.
It certainly is. I'm Bob Starr. Have a seat.
We heard you could hook us up with any NASA researcher.
Yes, I can. In the electronic classroom, we use two-way audio-video communications over the phone lines.
I've been doing a little research, and I found that NASA's Dryden Flight Research Center in California uses experimental planes to test out new futuristic ways of flight. It tested NASA's first space shuttle before it went into space.
That sounds risky, too. That must be where they find out if the new designs are going to really work.
Hey, I know a researcher who's an expert in stability. His name is Al Bowers. Let me try to contact him.
Hi, I'm Al Bowers, an aerospace engineer at NASA's Dryden Flight Research Center. I understand you have some questions about airplanes.
We have a lot of them. Could you tell us about weight, one of the four forces, and how it affects flight?
One way that weight affects an airplane is the way the weight is distributed. The weight is distributed on an airplane so that there's a balance point, and that balance point is called the center of gravity.
How does the center of gravity help you design planes?
I'm glad you asked, because we use the center of gravity to determine where to place the wings on an airplane. On a normal airplane, like this one, we place the wings just behind the center of gravity, and that helps to keep the front end of the airplane pointed forwards.
Our plane always flies to the right. Is there anything we can do to fix this problem?
That's the purpose of the tail. The tail of the airplane keeps the nose from going up too high or dropping too low or slicing off to the left or right. Here, let me show you. This is an F-104 Starfighter aircraft. It has the center of gravity just in front of the wings where the lift is produced, and the tail is on the back end of the airplane. All of that makes this a very stable aircraft.
Wow, what kind of plane is that next to you? I've never seen anything like that before.
Oh, this is the X-29. I'm sure you noticed right away that the wings are on backwards and that we put the tail on the front of the airplane.
Backwards? And a tail on the front?
Yes, even backwards we can make it work, with the tail on the front of the airplane, just like on Burt Rutan's airplane.
How can it fly like that?
Let me show you with this broomstick. This broomstick is like a traditional airplane, where the center of gravity is in front of the wings, and it's stable. If we move it to a new position, the broomstick just follows along. But the X-29 was unstable. It had the center of gravity behind the wings, and so it was like your egg crate airplane. And it didn't fly very well. But on the X-29, we had advanced technology in the form of very fast computers. Those computers could compensate for the instabilities in the airplane. Let's go back to the broomstick for a second. It's like your hand moving back and forth to compensate for the instability. And that was the way we were able to make the X-29 fly.
Wow, I never thought a plane like that would have been able to fly.
I guess we need to find our center of gravity and make sure it's in front of our lift.
Yeah, that'll make our plane more stable. Thanks for all your help, Mr. Bowers. Bye.